Welcome students. Today we solve the practice set 1.2 of the chapter Similarity. It is based on basic proportionality theorem and its application. The first is angle bisector of a triangle and the second is three parallel lines and their transversal. In first example, we have given three figures of triangle PQR and ray PM which intersect side QR into point M. We have to show that if ray PM is a bisector of QPR or not. In first example, how can we solve it? We have to show the ratio QM upon MR and PQ upon PR is equal. If they equal, then the PM is a bisector of QPR. Otherwise, it is not. In first figure, in triangle PQR, QM upon MR, put the values of QM and MR 3.5 upon 1.5. If we eliminate the decimal point, we get 35 upon 15. Simplify it. 5 7s are 35, 5 3s are 15. Therefore, we get 7 upon 3. Now, PQ upon PR, we put the values of PQ and PR, then we get 7 upon 3. From 1 and 2, we get QM upon MR is equal to PQ upon PR. These two ratios are equal, therefore we can say that ray PM is a bisector of angle QPR because of by converse of property of angle bisector of triangle. We can show all these two examples similarly. Okay. Now, second example. In the second example, we have given triangle PRQ and segment NM intersect side PR into N and PQ into M. We have to show that NM is parallel to RQ. For that, we use the converse of basic proportionality theorem. For that, we have to show the ratio PN and NR is equal to PM and PM upon MQ. For that, first of all, we have given the value of NR and PR. Therefore, we have to calculate the value of PN first by betweenness P dash N dash R. PN plus NR is equal to PR. Put the values and we get the value of PN 20 minus 80 is equal to 12. Similarly, here we have value of PQ and value of PM. Therefore, we have to calculate the value of MQ by betweenness P dash M dash Q. Therefore, PM plus MQ is equal to PQ. Put the values and calculate the value MQ is equal to 10. Now, we have to find out the ratios. PN upon NR. Put the values and get a simplest form. We get 3 upon 2. And the second ratio PM upon MQ, put the values of PM and MQ and get the simplest form. It is also a 3 upon 2. Therefore, from 1 and 2, we can write PM upon NR is equal to PM upon MQ. These ratios are equal. Therefore, we can say that segment NM is parallel to segment RQ by converse of basic proportionality theorem. Now, the third example. In this third example, in triangle M and P, segment NQ bisects angle M and P. And we have given the value of MN, PN and NQ. We have to calculate the value of QP. Here we use the property of angle bisector of a triangle. Therefore, in triangle M and P, segment NQ bisects angle M and P. Then our ratios are NQ upon QP is equal to MN upon PN by property of angle bisector of a triangle. Now, simply we put the values of NQ 2.5, QP as it is equal to 5 upon 7. Then the process is cross multiplication. 2.5 into 7 is equal to 5 into QP. This 5 goes on to left hand side and denominator. Here we eliminate the decimal point of 2.5, therefore 25 upon 10, therefore we get 25 into 7 upon 10 into 5. Now we have to calculate it. 5 ones are 5, 5 fives are 25, therefore we get 7 into 5 is equal to 35 and 10 ones are 10. QP is equal to 35 upon 10, therefore QP is equal to 3.5. Now the fifth example. In this fifth example we have given AB parallel to PQ parallel to DC, and we have given the value of AP, PD and QC. We have to find out the value of PQ. If we have given three parallel lines, obviously we have to use the property of three parallel lines and their transversal. Okay. AB parallel to PQ parallel to DC and segment AD and BC are transversal, then we get the intercept AP, PD, PQ and QC. By the property of three parallel lines and their transversal, we get the ratios AP upon PD is equal to PQ upon QC. Now put the values. 15 upon 12 is equal to PQ upon 14. Then cross multiplication, 15 into 14 is equal to PQ into 12. Now this 12 goes on to a right hand side, left hand side and get denominator to 15 into 14. Now calculate it. 2 6 are 12, 2 7 are 14 and 3 2s are 6 and 3 5s are 15. Therefore we get 5 into 7 is equal to 35 upon 2. Now divide this 35 by 2 and we get PQ is equal to 17.5. Okay. This is the fifth example. We will have to solve now the remaining examples in practice set 1.2.